All right, welcome to one of my favorite questions on LeetCode. It's number of islands. It's a fun question. There's kind of like a graphical aspect to it. I've personally been asked this in an interview, and I was really glad that I was able to see it here on LeetCode first. So this question, they give us a grid of land and water, where the 1 means this is land and 0 means it's water. And we want to count the number of islands. So they define island as being surrounded by water, and like outside of the grid, all of this is water. And it's connected, so an island is connected. So for example, in this example, we have 3 islands. These 2 up 4 form an island. This one here forms an island, and then the bottom 2 here forms an island. And we want to output. Okay, let's dive into an example. So here is our island. So we have 3 islands here. And then, what we do is we come through and we're scanning. And then we see a green. So we mark it as, now we have an island. So we keep on going. Now, if we didn't do anything, what happens when we come here? We are like, oh, we see another island. So now we mark it as 2. But then this would be incorrect because these islands are connected. So what we need is some way of identifying that this point is actually part of an island that we've already seen before. So what we'll do instead is when we hit our island, what we want to do is we want to mark it somehow. So, I've seen this island. So we mark it. And then when we continue on with our scanning, we're going to see like, oh, this is an island that I've seen before, so I don't need to worry about it. And then you keep on going. And then now when you hit another island, and it's not water or it's not land that you've seen before, this we can mark it as our second island. So now we're guaranteed that if we see land, it's part of a new island. Then we can do the same thing of clearing it out. Okay, so let's get back to it. Let's start with what that'll look like. So we have our island count. And ideally here we'd also have probably some sort of check on the grid to make sure that it's, there's stuff on our world. But for now, let's just continue. So for int row equals 0. Okay, that iterates through our rows, and now for all our columns. So column is going to be less than grid add row dot length. Okay, so now we have this, and we're going to check if grid at row at column is equal to 1. If it is, then we are going to mark our island. So let's give it the row and coordinate. So here, let's create another function, mark grid, and then with our position to mark. Okay, so here whenever we see an island, for sure, it's a new island because in our mark, we're gonna get rid of it. And then here, it will do island plus plus. Okay, well, not islands plus plus, my bad. Return islands, because we're done here. Okay, so let's look into how we can mark an island. So in here, we'll zoom in a little bit, and we'll see the following picture. So what we want to do first is when we hit one of these island spots, we want to mark it. So we mark it, and then afterwards, we want to check all its neighbors. So we want to check up, right, left, down, in no particular order. But first, we want to mark our island first. Okay, so we mark it, and we go up. And as we go up, we can see here, it's out of bounds, so there's nothing. We go right, there's nothing. And then we go left, there's nothing. And then we go down. So we go down here. And again, our first step is to mark the island. And now what happens is we're going to try and go up. So as this guy tries to go up, he's going to realize like, oh, this is a marked island. So when we go up, we need to check 1, is it marked? or is it water, or is there nothing there, right? Okay, so that's why he's not going to go up because he sees that it's marked, but they will go to the right. It's going to go right, and then we're going to mark it. And then here, as before, we're going to check up, nothing, right, nothing, left is already marked, so we go down. And then here, we will mark it. And this guy will do all the up, down, left, right, nothing, nothing. So he's going to return back. And here, he just finished this one, so he's done as well. We go back to this guy. This guy was actually in the middle of checking the right when we found something and did all of this. So now he can continue on with his list of jobs, right? So this is for each of these points, their list of jobs. So he just finished going right. So now I'm going to check left. And indeed, there's one at left. So we'll mark it. This will also do the up, down, left, right check, come back, and finally, we're back to here, and our whole island is marked, and we're free to continue on. And when we reach here, we'll be like, this is an island we've seen, and we can move on. Okay, so this, we're going to implement it in a recursive function. So when we see a grid, when we get something to mark, first of all, we're going to mark it. So here what you can do is you can mark it with anything that you won't see on the grid. So it could be 2, it could be 0. So 0 would mean you're sinking the island basically. But yeah, this could really be anything. We can put a minus if we want. Okay, so now we want to do our up, down, left, right. Now there's 2 ways of doing this. One is we could just say mark grid, and then to go up, we'd go up a row, so -1, and then to go to the next, stay on the same column. So we could do it like this, where you do +1, and then I guess left will be -1, and then right will be +1. But then there's a possibility that this row and column will be out of bounds. So then here instead you need a check. If row is greater than or equal to 0 and like it's within our world, then go ahead and mark it. But instead of this, what I'll do instead is I'm gonna do the check here. So I'm gonna check if row is greater than 0, and that at that place there is an island. So row -1 col. There is an island that we haven't seen before that we want to mark. Then I'll mark it. So this will help us because we're going to be calling this function a lot. And if we can do some simple checks before we have to call it, then it's going to save us having to call this function even more times. Okay, so I'm going to continue on checking. So here we want to make sure that row is less than grid.length -1 so that we can +1 without fear. And that at that place, there is an island. So that's what makes the islands connected, because their neighbors are also an island. Now we have our columns, so column greater than 0. And finally, we have our right side. So col is less than grid at this row, length -1, and there's something for us to mark. Okay, so that should handle that. We've marked it. So now those islands will no longer have 1, but instead we've transformed them into minus signs so that this guy won't pick it up again. And then we'll increment our island count and mark it. Okay, let's see if we get any compile errors. And then, cool, so it's accepted. And let's run through the runtime a little bit because this is a little bit more confusing. So here, let's assume that our grid has a size of m rows, n columns. So it's an n by n grid. So this for loop tells us that we're visiting every single point in our world. So here we already have O of m times n. But what about this mark function? This mark function is a recursive one that also goes up, down, left, right. So, that means if your whole world is an island, so if here's your world, what happens if this whole entire world this is your world? Then you'd be marking everything. So it seems as if this also has a runtime of O of n times n. So then if we proceeded with that idea of O m times n here, we would end up with O of m squared n squared for our final. But what we notice is how many points will we actually mark? We'll only mark as many points as there are in our grid. And once we mark a point, we'll never remark the same point. So even though we're calling this, and it could have a worst case of marking the whole grid, we're guaranteed that we will only mark as many points as there are in this grid. So in total, we're only going to mark O of m times n points. So in the end, it's really going to be m times n plus all the points that we've marked. And here, these two combined will still just be big O of m times n. So that's the runtime, and that's the end of today. I hope you enjoyed this problem. I really like this. And I'll see you on the next one.